All right. Good afternoon, class. We are looking at chapter 8, further application of trigonometric functions, 8.3 polar coordinates. We want to finish this off. So convert from rectangular coordinates to polar coordinates. Rectangular coordinates x, comma, y. Polar coordinates r, comma, theta. So we are going to look at some basic ones such as a comma 0 for a rectangular coordinate system. It happened to be the same for polar coordinates because we go with r, so the same distance a, and it makes the angle 0 because it's on the x-axis or the polar axis. Of course, we are going with a being positive in all of these cases. Now, if you look at this point, has coordinates 0a when it comes to rectangular coordinate system. This makes a 90-degree angle or pi over 2. So r comma theta. R has the distance a and the angle is pi over 2. The point 0a. Now the point minus a on the rectangular coordinate system with r comma theta. R is the same a, but now this one is pi, the angle 180 degrees or pi, a comma pi. In essence, we are looking at the quadrantal angles. We are looking at points on the x-axis, positive, negative side, on the y-axis, positive, and now let's look at the negative side. On the negative side, if we have the distance a, it's 0 minus a as far as x comma y is concerned, 0 minus a. As far as the polar coordinates, again, we have the same distance a. However, this angle is now 3 pi over 2, so we say a comma 3 pi over 2. It's pretty straightforward. Convert from rectangular coordinates to polar coordinates. The pair is 2 comma negative 2. It's really a good practice to plot the pair first and then determine r comma theta. So the pair on the rectangular coordinate system, 2 units to the right, 2 units down. So 2 to the right, 2 units down. It's very straightforward, everybody. So now we are interested in finding the r and theta. R is x squared plus y squared equals r squared. So that means r is the square root of that. So I hope everybody knows that if this is the case, x squared plus y squared equals r squared, therefore r must be the square root of x squared, which is 2 squared, plus y squared, which is negative 2 quantity squared. Each one is 4. So we get 8. 8 is 4 times 2. 4 comes out as 2. 2 remains. It's precisely 2 square root of 2. As far as the angle is concerned, if tan of theta is y over x, theta must be tan inverse of y over x. Again, we have this. Therefore, theta is tan inverse of y over x minus 2 over 2. So tan inverse of negative 1. And as you know, tan inverse of negative 1 is negative power 4. Remember, inverse functions have a unique solution. And tan, the restriction was from negative power 2 to power 2. That means quadrant 4, quadrant 1, negative puts us in quadrant 4. Because if it's 1, it's power 4. Remember, power 4 would be the reference arc. So minus the power 4. Therefore, we have the r 2 square root of 2 and theta minus pi over 4. And that's one representation, and it's fine. Now, let's choose r to be positive, so that means the same thing, and theta between 0 and 2 pi. We don't want a negative edge. So all you have to do, add 2 pi. If you want it to be positive, that's the idea. When they say between 0 and 2 pi, the first revolution, minus pi over 4, make it positive. How do you make it positive? Add multiples of 2 pi until it becomes positive. All you have to do is just add 2 pi. 2 pi and negative pi over 4. 2 pi is 8 pi over 4. With minus pi over 4 becomes 7 pi over 4. So that's this case. On the other hand, if we want r to be negative, we make this one negative, and then we just add, and again, it's you want it to be between 0 to 2 pi. That means if the first revolution. So add pi. You have to add 2 pi to keep the r positive, and you have to add odd multiples of pi. That means add pi, 3 pi, 5 pi, 7 pi, okay, things of that nature. So in this case, all you have to do, add pi. So if I add pi, and pi is 4 pi over 4 to negative pi over 4, I get 3 pi over 4, and I'm done. It's that simple, everybody. All right, rectangular has coordinates x comma y, polar has coordinates r comma theta, and the relationship is as follows: x squared plus y squared equals r squared. Tan theta is y over x, or theta is tan inverse of y over x, okay? And adjust for quadrant. If we are dealing with the first quadrant, obviously r is that tan, and theta is tan inverse of y over x. If we are in the second quadrant, we have to add a pi to tan inverse of y over x. If we are in the third quadrant, that we have to add pi. And if we are in the fourth quadrant, we don't have anything to worry about. That's now you can memorize that, or just figure it out when you look at the quadrant what you need to do. You really don't have to um, memorize this, but it's up to you in any event. And again, remember the first quadrant and the third quadrant tangent is positive, right? So quadrant 1 or 4 tan inverse of y over x. And quadrant 2 or 3 tan inverse of y over x, we need to add pi. That's the idea, okay? So it's pretty straightforward, everybody. We are going to move on. So remember that. Transform equations between polar and rectangular forms. In this case, r equals 4 sine theta to rectangular. Identify the graph. In some cases, we can. In some cases, we cannot. And so in this case, we can. And reminding everybody of the following. Number one, when we want to go from rectangular, which is x comma y, to polar, which is r comma theta, we need to remember x squared plus y squared equals r squared. Tan theta is y over x. Always adjust for the quadrant. Polar, which is r comma theta. If you want to go to rectangular, remember x is r cosine theta, y equals r sine theta. So when you have r equals 4 sine theta, okay, the technique is remembering r squared is x squared plus y squared and y equals r sine theta. So if we multiply both sides by r, what happens? The left side becomes r squared and the right side becomes 4r sine theta. R squared is x squared plus y squared. This is r squared, everybody. So the left side becomes r squared or x squared plus y squared. The right side 4r sine theta. If r sine theta is y, then this is 4 of it. And now this we know how to handle. We bring the 4y to the left. We put these two together and we are going to complete this square. Notice b is minus 4. I hope you remember completing this square. Divide b by 2, you get minus 2. And if you square that, you get 4. So we need to add 4 to that to make it a perfect square trinomial, which is always the variable x, y, z, in this case y, and b over 2, including the sign. So this becomes y and b over 2. That means y minus 2 quantity squared. And this is a circle with center located at 0, 2, and the radius 4. So let me actually erase my work now. So reminding you, x squared plus y squared equals r squared as a center at 0, 0, x minus h quantity squared plus y minus k quantity squared equals r squared with c located at h comma k, right? I hope everybody remembers that. And therefore, it's a circle centered at 0, comma 2, 0, comma 2, radius square root of 4. Which makes it 2. We are going to move on with more examples. We want to transform equations between polar and rectangular forms again. 3x squared plus 3y squared equals 2x, and we want to take it to polar form. So again, we remember this. So first and foremost, on the left side, we can factor the 3 out. And again, we remember, simply put r squared is x squared plus y squared. X equals r cosine theta and y is r sine theta. Just reminding you, we have it here already. Therefore, we are going to replace this with r squared and replace the x with r cosine theta. I can drop the R from the right side and change this to just R. And normally we solve for R for the polar form. So R is 2/3 cosine theta. Pretty straightforward, everybody. In this case, R is 6 cosine theta, and we want to take it to the rectangular format and identify the graph. So, reminding everyone of what was discussed previously, the relationship between the two formats and circles we are supposed to know. Now, whenever we have R and sine or cosine, the technique actually is to multiply both sides by R. So this is a technique that you need to learn, everybody. So let's multiply both sides by R. So we get R squared here, 6R cosine theta. R squared can be replaced with x squared plus y squared, or cosine theta can be replaced with x. Therefore, x squared plus y squared is 6x. And we are going to work on that. So we are going to move 6x to the left and put it next to x squared. It's important to remember x minus h quantity squared plus y minus k quantity squared equals r squared. And this requires a number, so it becomes a perfect square trinomial. Remember, b is minus 6. You have to divide it by 2. Then you have to square that. And that's the number we need to make the parentheses into a perfect square trinomial. So we add number 9 to both sides. Okay, everybody? So what happens is this one is a perfect square trinomial. The variable, whatever, x, y, z, the variable x, and b over 2. Again, that means plus b over 2. It happened to be negative, so including the sign. If it was positive 3, you would say x plus 3 squared. If it's negative 3, you would say x minus 3 squared. So x minus 3 squared plus y squared equals 9. So what do we have? According to this formula, we have a circle centered at h and k. That means centered at positive 3 and 0. Remember, x minus h gives you positive h. Positive 3 and 0. Radius is square root of 9. So let me let r is square root of 9, which gives us 3. Okay, everybody. So pretty straightforward. We are going to move on, everybody. So reminding you of circles. All right. The next one says given 4xy equals 9, change it to polar. So 4xy equals 9. X equals r cosine theta, y equals r sine theta. So we get 4 times r cosine theta times r sine theta equals 9. So we have a 4 times r squared sine theta cosine theta equals 9. You can sort of leave it like that, but notice if I rewrite this as follows, 2 r squared, 2 sine theta cosine theta equals 9. I can replace this with sine 2 theta. And that would be the final answer. So we've looked at quite a few examples, and we are going to do a few more just to make sure we are comfortable with this concept. We continue with transformation from one format to the next. So transform equations between polar and rectangular forms. So obviously this is a rectangular form. We want to go to polar. And reminding you that x squared plus y squared is what? R squared. X is what? R cosine theta. So let's plug in. Divide by R, both sides. So the left side R squared becomes R, and the right side R goes away. R equals cosine. In essence, R equals cosine theta represents a circle. Part B, y equals -3. Well, replace the y with what? R sine theta. As you know, y equals -3 is a horizontal line, right? So R sine theta equals a number, represents a horizontal. R equals sine theta plus 1. Again, in this situation, the technique is to multiply by R, multiply both sides by R. So the result is, this is R squared, this is R sine theta, and this is R. Therefore, first let me just write the left side. So this is R squared. And in this case, we have a polar. We want to change it to rectangular. So to do so, R squared, we replace it with x squared plus y squared. R sine theta, we replace it with y. What about R? We replace it with square root of x squared plus y squared. So again, R squared, x squared plus y squared. R sine theta, y. R is the same as this one under the square root. So pretty straightforward, everybody. R equals 4. Now, this is the polar format. This is the simplest form of representing a circle using polar. R equals a number. We want to go to rectangular format. And to do so, the technique is to square both sides. R squared equals 4 squared. R squared is x squared plus y squared equals 16. So as you can see, this is a circle centered at 0, 0 with the radius 4. And the simplest format would be simply R equals a number, R equals 4. That's how you would represent that. R equals sine theta plus cosine theta. And I hope by now everybody knows the technique is whenever you have R and sine or R and cosine or both is to multiply both sides by R. That would be the technique, everybody. And so if I multiply by R, this is what I get. We are going to replace it accordingly. What do we replace it with? Well, it's very simple. This, you know, this one is R. Is R squared. Replace it with x squared plus y squared. This is R sine theta. Replace it with y. This is R cosine theta. Replace it with x. You can always bring the y and bring it to this side. Same thing with x. Combine this with x squared. This combine this one with y squared and figure out what you have, which is actually a circle. But uh, that's not the purpose of this part. Now, before I move on to the next page and the last page, I want you to pay attention to this page. We are going to transform from one format to the next, from rectangular to polar, rectangular to polar, vice versa, vice versa. And there are some techniques involved. And with practice, you know which technique to use when. Okay? It's very straightforward, everybody. Now we want to convert from rectangular to polar coordinates where the pair is given as -1 comma negative square root of 3. So in a rectangular coordinate system, we go 1 to the left and square root of 3 down minus square root of 3. Remember, square root of 3 is about 1.71 roughly. So you graph this in rectangular coordinate system, and that is, of course, since both of them are negative, they give us the third quadrant. So x is -1, y is minus square root of 3. And so you need to figure out the r, and you need to figure out the theta. And that's what we're going to work. So if x squared plus y squared is equal to r squared, r must be the square root of that, right? So r is the square root of x squared plus y squared. Replace the x with -1. Replace the y with negative square root of 3. We get 4 and square root of 4 is 2. So we got the r. Now we need to find the theta. And to find the theta is basically tangent theta is y over x, or theta is the tan inverse of that. And square root of 3, tan of theta equals square root of 3 happen to be a common arc, everybody. The answer is pi over 3. However, you have to adjust for the quadrant. Remember, tangent is positive in the first and the third quadrant. And this belongs to the third quadrant. Just look, that's why you graph, plot the point to make sure you know the location. Third quadrant, we must add pi. Remember that. Again, just the answer is pi over 3. Perfect. You got that. But you should know now in the third quadrant, you have to add pi. Pi is 3 pi over 3, and pi over 3 adds up to 4 pi over 3. Therefore, the answer is r comma theta, 2 comma 4 pi over 3.